I'd say that synthesis are the easiest reactions to predict the products for. They're very easily recognizable, which is fortunate. So the word synthesis, or to synthesize, means to make or to put together. So the way that we recognize a synthesis reaction is there's two different things that you can look for. Either the reactants are two elements, okay, which is a dead giveaway, because if you have two elements, the only thing that they can do is react and form one compound. Or there is only one product. Okay. So the steps, very simple. You need to correctly write the reactant formulas. That's always a given. Secondly, determine the formula of the product. If it's an ionic compound, you're going to use the charges to determine the formula. Add phases and balance. Now, about adding phases, I wanted to go over that a little bit. This hopefully is review. If you are trying to determine the phase of an element, okay, so that could be anything from sodium to phosphorus to any of your diatomics, remember, all you need to do is check the periodic table. At the very beginning of the year, we went over how to use the periodic table to determine the phase of an element using the colors and the letters. Now, every periodic table is going to be a little bit different in how they represent that, but most of them should contain that information. So anything that's metallic is going to be a solid, except for mercury, right? Mercury is that one blue one. A lot of your nonmetals will be gases. Some of them will be solids. It just depends. The only other liquid, for instance, on the periodic table will be bromine, etc. Okay. A little bit of an exception. If it is a diatomic, and I know I just said bromine was a liquid. I know I did that. If it's a diatomic, assume it's gaseous. Okay? Just do it. Trust me. It'll make life easier. If you have a molecular compound, molecular meaning two or more nonmetals, your molecular compounds are either going to be liquid or gas. And your problem should probably tell you whether it's a liquid or a gas. But molecular compounds, by definition, are usually liquids or gases at room temperature. Now, if it's an ionic compound, okay, ionic compounds are characterized by their very high melting and boiling points. So your ionic compounds are going to be in the solid phase. Now, if we are talking about a reaction that is happening in solution, in other words, well, yeah, dissolved in water. So if the reaction is in solution, you're going to have to check solubility rules. Now, we'll come back to that. That becomes really, really important when we discuss double replacement reactions. Synthesis reactions, however, do not occur in solution. In other words, this stuff is not dissolved in water. All right, so you'll never have a synthesis reaction that has, or a synthesis reactant or product that has aqueous. Okay, so if the reaction is in solution, you're probably going to have some aqueous things. That is not the case here. Okay, so the only phases that we should see with synthesis reactions are solids, liquids, and gases. Okay, do not use aqueous. Just a heads up, it's going to be the same thing for the decomposition reactions as well. Okay, so only solids, liquids, and gases. If it's an element, check the periodic table. If it's diatomic, assume it's gas. Molecular compounds will tell you. Ionic compounds, they're going to be solid. Okay, just assume that they're solid. So the best thing that you can do for yourself when you're going forward with these problems is make sure that you are familiar with your charges, or just make sure you have a periodic table next to you and you know how to read it. So sodium metal reacts with oxygen gas. So sodium, if I check the periodic table, is a solid. Reacts with oxygen, I'm not going to forget my diatomics. Right, and that is a gas, of course, okay, because it is a diatomic. Recognizable as a synthesis reaction because these are two elements. Yes, this has a bond, but we've talked about that. It's a molecular compound, okay, so that's why it's still elemental. And we are going to form a product. So sodium is going to be the cation, oxygen is going to be the anion. It doesn't matter which order they're written here, but it does matter in your ultimate compound. Remember that the metal always comes first, followed by the nonmetal, or the cation followed by the anion. So sodium is a 1 plus ion, oxide is a 2 minus. So this is going to be Na2O. That gives me an ionic compound, according to what I just talked about. Okay, we're not happening in solution, so I have to assume that this ionic compound is solid. Alright, and then I just have to go back and balance. Normally we'd start with our metals first, according to Minnow. That's not going to work, or it would add another step. I'm going to skip to oxygen. I've got 2 of them here and only 1 here. So I need to produce 2 sodium oxide compounds, which gives me 4 sodiums. So I need a 4 right there. And then this would, of course, be 1. If you had to start with a 2 here and then figure it out, that's fine. I've told you before, I'll tell you it again, it's supposed to be guess and check. That's the section. Done. Next we got calcium, which is a metal. If I check the periodic table, I don't know. Reacts with nitrogen, so there's another diatomic, which I know are going to be my gases. Okay, got some fun charges going on here. We've got Ca2 plus and N3 minus, so this is going to be Ca3 N2. I doubted myself for a second there, but yeah, that's right. And again, we've got an ionic compound, so it's going to be in the solid phase. Nitrogen is already balanced. Calcium is not, but I can fix that pretty easily by putting a 3 right here. Again, synthesis reaction. 2 elements reacting to form 1 compound. Only 1 product. Super easy. Finally, overkill if anything. Lithium. Again, another metal. It's solid. Reacts with phosphorus. This is a non-metal, but it is not diatomic. Okay, so I'm going to check the periodic table, and it is a solid at room temperature. Okay, this is another 3 minus ion when it loses, or I'm sorry, gains its electrons. This one only loses 1, so it's going to be a 1 plus. My product is lithium phosphide, which is Li3P, which is also going to be a solid. Okay, to balance this, I just need a 3 right out here. And done. Alright, so synthesis reactions, 2 elements reacting to form 1 compound.